The distance between points 2, 3 and x, negative 5 is a distance of 10 units. So if we plot 2, 3, 2, 1, 2, 3, that's the dot that I know. X, negative 5. What x, negative 5 implies is that you're at a y value of negative 5, so go down here. Just put a dotted line so you know which one you're talking about. And then the distance is 10 units. So let's see if I can get this done. I'll go with the purple line, I'll do that. I'm going to draw a line from here to here, purple. I should be able to take that, highlight it. I should be able to say edit. This is where if I had my, whatever. I'm gonna just rotate it. Maybe a little bit more. So what I've done is I've drawn a line that's about 10 units long. Okay, and so that's the approximate visualization for you. What does that tell you about this problem?
Should be any of those points.
How many? 2. So in this problem, we have 2 locations. So from that purple dot, 10 units, 10 inches, centimeters, whatever it is, down to the negative 5 line, and then there are going to be 2 solutions to this. So how many solutions are possible? 2. That's the visualization. So you want to be able to visualize that before you start the problem. Find the possible values. So what do we have to do? Does anybody know what this is setting up?
I just have a question.
We must use the distance formula. Now, I will tell you, if you set it up a certain way, it makes your life a little bit more difficult. If you set it up the way I show you, you should be better off. So whenever you are dealing with it could be the x or the y that's missing, put the variable first. So when you set up this distance formula, we're going to go x minus 2 quantity squared plus, since I used x first, I have to use the negative 5 first. Negative 5 minus 3 quantity squared. That is your distance, right? As long as you take the square root. Some students write out the distance formula with d squared, it doesn't matter. What do we know for d though? So d is not going to just be the distance formula because this will actually be 10. So you can substitute the 10 for that d. So now what's missing? The x. So how do I get at that x? What do you have to do? Square both sides. What is negative 5 minus 3? Negative 8. Square it. 64. 10 squared? 100. So what do you have to do to solve now? We did not square that. I squared both sides of the equation, so that gets rid of the radical. Gets rid of the radical over everything. So now we're going to subtract 64. What do we do here? Now this is something we squared, so we square root both sides. How would I get two answers out of this? Plus or minus. That's the key to this problem. And now I add 2 at the end. So this is 2 plus or minus 6. Those are nice numbers. So what's 2 plus 6? 2 minus 6. So this is that point, and this is that point. So the 2 points would be -4, -5, and 8, -5. My dots on the graph are just for visualization. I did not graph them to be exact. All I did is put a line approximately where it's going to be. So it's kind of like I expect my answer to be somewhere in this area and somewhere in this area. Yeah, that's. We can do the same type of problem with the midpoint formula. So I can give you the midpoint, and then I can give you another endpoint, and then you can solve for one of the missing pieces. So the midpoint of segment is 2, 5. So put a dot at 2, 5. 2 to the right, 1, 2, 3, 4, 5. That's the midpoint. One of the endpoints is -3, -4. 1, 2, 3. 1, 2, 3, 4. Correct? Approximately, where is the other endpoint? You know, it's going to go towards the midpoint, so you kind of have to measure where you're going. You know, it's somewhere up in that area, correct? If that's the midpoint, you would draw a straight line through both of these, right? Because that's the midpoint. Right. So you got to go towards the midpoint and then to the other side of the line. Yeah. This one will not have two answers like the distance did. So use graph to visualize the problem. We did that. Find the coordinates. So when you go to set up the midpoint formula, let's just call that point x and y, right? We're going to find a new x and y. So I have x and y and 2 and 5 with the midpoint of -3 and -4. So when you go to do the midpoint formula, you add the two endpoints together.
Wait, the midpoint is 2 and 5.
Did I just switch that around?
Yeah.
I'm sorry. Yeah. Alright, so -3, -4, thank you. And let's switch colors. Midpoint is 2, 5. Thank you. So what the formula then would look like is your x plus -3 over 2, comma, y plus a -4 over 2 must equal 2, 5. I don't know what these x's and y's are, but if somebody did the midpoint formula, that's the answer they'd get. 2, 5. So set the x stuff equal to 2. Set the y stuff equal to 5. And then solving these is kind of the same in both cases. What do you have to do first?
Multiply by 2.
Multiply by 2. I'm just going to write that x minus 3 is equal to 4. Then add 3. So x is 7. Over here, the y values. Multiply by 2. And I get y minus 4 is equal to 10. Add the 4. And I'm getting a y that's 14. So if you go to graph this thing, 1, 2, 3, 4, 5, 6, 7, 11, 12, 13, 14. Does that point look like it, does it look like it works? So 7, 14.